name is Saishriya and welcome to Agora Math Circle. Before you continue watching this video, make sure to subscribe to the Agora Math Circle channel. This is Junior Intermediate and we're going to be learning about geometry. So let's get started. So, what is geometry? Geometry is a branch of mathematics used to study shapes, sizes, and properties of space. And geometry consists of two words, geo and metron. Geo means earth and metron means measurements. Now let's learn about six different items. Now, first let's learn about a point. A point is a dot drawn by a pencil and it has 0 dimensions. And it looks like this. Let's go to number 2. A line segment is the distance between 2 points and it has to be straight. And there might be other points through the distance between these 2 points, A and B. Now let's learn about number 3, a curve. Now, once again, it is the distance between 2 points, such as A and B, except the distance doesn't have to be straight. It can be curved like this. It can be curved in any way. And number 4 is a plane. A plane is a flat region with only 2 dimensions. And number 5 is an angle. And an angle is used to measure deviation, not distance. So let's say we have 2 line segments, AB and then CD, and it intersects right here. And we have an angle formed right here. This angle is used to measure deviation. Let's go to number 5. Number 5 is planar shapes. And these are basically shapes that are drawn using line segments and curves. An example would be a triangle. As you can see, there are 3 line segments, AB, BC, and AC. So there are 3 line segments in a triangle. Believe it or not, a circle is also a planar shape. That is because it consists of curves, which come in any form. So this is called a curve, which measures the distance between 2 points using a circular shape. So now you know about the introduction to geometry. Now let's go ahead and learn more about angles. An angle is measured by the amount of deviation in an intersecting angle. And an angle is usually measured in degrees. So now let's go ahead and look at these 6 different types of angles. Let's first start with the right angle. The right angle is actually measured 90 degrees. And a right angle is in an L design. I guess you could say that this is sort of a base for all the angles, because using this 90-degree angle, we can talk about the acute angle and the obtuse angle. So now let's move on to the acute angle. The acute angle is less than 90 degrees. And if you guys don't understand why, let me show you. Well, this is 90 degrees, and this is less than 90 degrees, which is why it's an acute angle. So remember, whenever an angle is less than 90 degrees, it's an acute angle. Now let's move on to an obtuse angle. An obtuse angle is basically the opposite of an acute angle. An obtuse angle is when the angle is more than 90 degrees. And if you see this over here is actually 90 degrees. And if you can see, this is more than that. It's increasing 90 degrees, which is why it's known as an obtuse angle. Now let's move on to a straight angle. And a straight angle, as you can tell, is because it has a straight line going like this. And when there's a straight line going like this, it's actually 180 degrees. And you can write that by doing a semicircle right here and writing 180 degrees. So remember, whenever you see a straight line, know that it's 180 degrees. Now let's move on to a reflex angle. And just like the straight or the acute angle and the obtuse angle, there's something called the reflex angle. And the reflex angle is when the angle is more than 180 degrees. So sorry for the messy line, but this is 180. And if you can see, it exceeds that, which is why it's known as a reflex angle. And there's not something for the opposite of a reflex angle, which means it's less than 180 degrees, because that wouldn't make sense, since over here we obviously have an obtuse angle that's already less than 180 degrees. And these 2 as well. Now let's move on to the 360-degree angle. And this is basically just a full circle. It includes all of them. It includes a right angle, and 180. So it has this and it has this. So it's the whole thing. So remember, a 360-degree angle is basically just a full circle. So this is what you need to know about angles. Now let's look at polygons and various examples of it. First of all, you might be wondering, what is a polygon? A polygon is a closed shape with 3 or more sides and angles. Let's look at some examples of it. First, let's look at a right triangle, which has 3 sides. The sum of all the angles is 180 degrees. Now, why is it called a right triangle? That's because it has one right angle, which we learned about in the previous lesson. And we learned that a right angle has 90 degrees. So as you can see here, this triangle has 90 degrees. Let's look at the second one, an acute angle. You know that acute means below 90 degrees. So you must know that all of the angles in the acute triangle is less than 90 degrees, and the sum of it is 180 degrees. This triangle also has 3 sides. As you know, all triangles have 3 sides. Here's an example of it. As you can see, all of the angles are acute, meaning less than 90. Let's look at the next one. By the name, you must guess that the angles is obtuse. Now, one of the angles in an obtuse triangle are obtuse. That is because all angles cannot be obtuse. Only one of it can be. One angle is above 90 degrees and the other 2 is less than 90 degrees. As you can see here, this is the obtuse angle and these 2 are acute. And one angle is obtuse, meaning more than 90 degrees but less than 180 degrees. And the sum of all of the angles is 180 degrees. Let's look at the fourth one, an equilateral triangle. Now, an equilateral triangle, as you can see, has a keyword, equal, meaning that all sides and angles are equal. As you can see here, all of the sides are equal with the same length, and the angles are all 60. Now, you know that all angles in a triangle have to be 60, and you know that all angles are equal. So what do you have to do? You have to divide 180 by 3 to get 60. So you know that all angles are going to be 60. So let's look at one of the last ones, the isosceles triangle. Now, in an isosceles triangle, 2 angles are equal and 1 angle is not. As you can see here, these 2 angles and sides are equal, as you can see. But one side is less than or greater than those 2 angles. And the sum of all of the angles is 180. Let's learn about the last one, which is a scalene triangle. It also has 3 sides, and the sum of all of the angles is 180. And the particular thing about a scalene triangle is that all sides are different, so none of them are the same, and the angles also vary. So one example would be a 30-degree, 40-degree, and 50-degree triangle. It all has different sides, and it has different angles. So now you know about triangles and polygons. Now let's look at some other types of polygons, mainly quadrilaterals. Let's look at some examples together. Let's look at a square first. A square has 4 sides, as you all know, and all 4 sides are equal, and they're all equal to 90 degrees. As you can see here, all sides are equal, and they're all right angles. And you show that by putting a little box around it. Let's look at the second one, rhombuses. Rhombuses also have 4 sides. All 4 sides are equal, but the thing that differs it from squares is that none of the angles are equal to 90 degrees, and the total number of angles is equal to 360 degrees. And this is an example of a rhombus. As you can see, it kind of looks like a diamond, and all of the sides are equal, which makes it. And you do that by putting a line over it. Let's look at the third one, parallelograms. Parallelograms also have 4 sides, and parallelograms basically has the word parallel in it, and that shows that 2 parallel sides are equal to each other, but the other ones are not equal to each other. Also, none of the angles are equal to 90 degrees, and the total number of angles is equal to 360 degrees. As you can see here, none of the angles are equal to 90 degrees, but these 2 are parallel to each other, and these 2 are parallel to each other. Let's look at the fourth one, a trapezoid. A trapezoid is also a quadrilateral, meaning it has 4 sides, and 2 sides are parallel, and others are not, and the total number of angles is equal to 360 degrees. As you can see here, these 2 are parallel, but these 2 are not. And if you notice, if this keeps on going on, some point it will intersect, which shows that it's not parallel. Well, if you were going to do these two and make it keep on going, it would never intersect. So that shows and it proves that it's actually parallel. And let's look at the fifth one, which is a rectangle. It also has 4 sides, and 2 parallel sides are equal to each other, but 2 are not. As you can see, these 2 are equal to each other, and these 2 are equal to each other, but these 2 are not equal to each other. And all angles are equal to 90 degrees, and the total number of angles is equal to 360 degrees. And they're all equal to 90 degrees, meaning that they're all right angles. And this is how it looks like. And these are parallel, these 2 are parallel, and they're not all equal to each other, but these 2 are parallel, and these 2 are parallel. Let's look at the last one, which is a pentagon. A pentagon is not a quadrilateral because it has 5 sides, and the total number of angles it has is 540 degrees, and this is what it looks like. Here's a type of a pentagon. This is not how necessarily it has to look like, and this one has 5 sides if you can count 1, 2, 3, 4, and 5. So now you know more about quadrilaterals, pentagons, and other types of polygons. So now let's move on to area and perimeter. And before we start on, I just want to say, in area and perimeter, we're going to be finding the area and perimeter of a square and a rectangle. So what's an area? Well, an area is basically the space within the boundaries. So it's basically the space inside here, which is why I put the area inside here. What's a perimeter? The perimeter is actually the boundary itself. So in case you guys don't know what the boundary is, let's say this is a playground. And the perimeter would be this over here. The lines over here. The outside right here. And the area would be the space inside. And this goes for all. So now let's move on to actually finding the area and perimeter. So let's first start with the area of a square. And so we all know that squares have equal length, which means that all the sides are equal to the same number. So in this case, we don't need to write length or width. We can just use one. And in this case, I'm going to use length because I think it makes sense more. So this is going to be length over here. Length, 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 and length. And to find the area of a square, what you need to do is you need to multiply one length by the other. And in a rectangle or any other shape, we basically say length times width. But since they're both the same number or they're both the same length, we don't need to use 2 different variables. So we just do length times length, which is length squared. And an example we can use is, let's say the length is equal to 2. So basically, here we're doing 2 times 2. And what's 2 times 2? 2 times 2 is 4. So the area is 4. So that's basically how you solve the area in a square. Now let's move on to a rectangle. Now in a rectangle, as I've already said, there's 2 different lengths. So we use length and width since there are 2 different sizes. So to find out the area in a rectangle, it's basically just the same exact thing. As we multiply the sides, these 2 sides, we're going to do the same thing. We multiply the length by width. So now let's go ahead and do that. So let's say that since we have to have 2 different lengths, let's say that this is 6, and so the length is 6, and the width is equal to 3. So what do we have to do? We have to multiply length times width. And that is 6 times 3. And 6 times 3 is 18. So the area would be 18. So that's how you solve the area for square and rectangle. And in case you guys didn't notice, it's actually pretty related or pretty close to each other, except for the variables change. So now let's move on to the perimeter. And as we've said, the perimeter is the outside over here. So in this case, we're not multiplying, but we're adding. So basically, since we have all the sides, in a square and in a rectangle, we have 4 sides. So what we're basically adding is this side, plus this side, plus this side, plus this side. And in a square, that would be 4L, because we're doing L plus L plus L plus L plus L. And that's 4L. So that's how you can do it. So let's go back here, and we said, what did we say? The length is actually 2. So the perimeter would be 4 times 2. So in this case, the perimeter would be 8. Now let's move on to the perimeter in a rectangle. So in a rectangle, we basically do the same exact thing. We do length. Actually, these two are wrong. So I actually wrote down variables wrong. So these two are the same as we can see over here. Length and length, width and width. Over here. So we basically do the same exact thing as we did over here. We do length plus width plus width. And when we do that, we get 2L plus 2W. And another way, or a common way that we write it, is 2 times L plus W. And you guys might be wondering why. And if you simplify this, you actually get the same thing. 2 times L is 2L plus 2 times W is 2W. So at the end, you get the same thing. So now let's go ahead and try that for 6 and 3. So we get 2 times 6 plus 3. And if you remember PEMDAS, it's first solving the parentheses, and then we move on to the multiplication and the division. So we get 2 times 6 plus 3 is 9. So we get 18 again. So this is how you solve perimeter and area for a square and rectangle. Now in area and perimeter, we actually have something called units. So let's go ahead and solve some problems using units in area and perimeter. So over here we have the same problems or same numbers that we used last time, which are 2 and 2. Now the last problem, I said that we used a playground. Now let's say we're making a miniature playground since we're using centimeters. So we're making a miniature playground for a project, and we have 2 centimeters by 2 centimeters. And we need to find the area. So let's go ahead and write it down. 2 cm centimeters times 2 centimeters. Now, if you guys noticed in the last problem, when we first started to find out what area was, I used length instead of numbers. So I did L length times length, or L. And I did L square, since we're multiplying it into itself times 2. So we got L squared. Now at the same time, when we solve this problem here, we get 2 times 2, which is 2 squared. But we can simplify 2 squared to get 4. Now we do the same thing with the units as well. So we get centimeters times centimeters is centimeters squared. And since we can't simplify it, obviously, we just leave it that way. Now in perimeter, I had said that we don't really need to multiply anything. So when finding the perimeter, we don't need to add squared, it's just centimeters. So let's go ahead and do the same thing for the square. So as I said, it's 4 times length. So in this case, it's 4 times 2 centimeters, in which we get 8 centimeters. Now let's move on to a rectangle in area and perimeter. So we have 6 centimeters times 3 centimeters. Pretend we're trying to make a bigger playground model. So we get 6 centimeters times 3 centimeters. So we do the same exact thing as we did over here. We get 6 centimeters times 3 centimeters. So we get 6 times 3 is 18. And since we're multiplying centimeters into itself, it becomes centimeters squared. So we get 18 centimeters squared. And I just want to include that the units can differ. It doesn't always have to be centimeters. It can be, let's say, inches. It can be feet. It can be yards. So it can be anything. And so now let's move on to perimeter. So we have 2 times 6 centimeters plus 3 centimeters. So we basically get 2 times 9 centimeters. And that's going to be 18 centimeters. So that's how you solve area and perimeter using units. Now let's learn more about the circle. There's 2 special properties of the circle. First of all points in the circle has an equal distance from the center point, and that distance is called the radius. This distance, let's say this is the point we're trying to solve for, A. The distance between the center point and A is same as the distance between the center point and B. So, you can use the radius to solve for the diameter, the perimeter, and the area. First, let's learn how to solve for the diameter. The diameter is basically 2 times r. So if r were 3, what would be the diameter? It would be 2 times 3, which is 6. Now let's learn about the perimeter, or the circumference, as we call it in the circle. The circumference is basically 2 times pi times r. And we know that the diameter is 2 times r. So we can conclude that 2r is equal to d. So the perimeter, or the circumference, is actually pi d. So let's say that our radius is 3. We know that our diameter is 6. So this would be 6 pi. And you can leave pi as it is. Now let's learn about the area. Now the area is basically pi times r, which is basically equal to pi times r squared. Now once again, if r were 3, well, we know that pi stays the same. And we know that r times r, and r is 3. So 3 times 3 is 9. So it's pi times 9, which is 9 pi. Now let's do an example problem together. So r is equal to 5. The radius is equal to 5. We have to solve for the area in terms of pi. So we know that the area is equal to pi times r times r. So we know that r is equal to 5. So 5 times 5, or 5 squared, is equal to 25. And you have to solve in terms of pi. So that would be 25 pi. So if you still don't understand, try attempting the practice problems in the lecture note. Now let's learn about the triangles. Now in the triangle we can solve for perimeter and area. Now how to solve for the perimeter is we have to add all of the sides. So this is side 1, side 2, and side 3. Let's say that this side is 3. That side is 5, and this side is 9. What would be the perimeter? Let's solve together. So that would be 3 plus 5 plus 9. 3 plus 5 is 8, and 8 plus 9 is 17. So the perimeter would be 17. Now let's solve for the area. Now let's say that the base is 3. And the height is 2. Now how would you solve for the area? Well, to solve for the area, you have to multiply the base times the height and divide it by 2. Another way to say this is 1/2 times b, which is the base, times h, which is the height. So let's solve if b is 3 and h is 2. So that would be 1/2 times 3 times 2. Now what can we do here to simplify it further? Well, we know that there's a 2 in the denominator and a 2 here. So what can we do? We can just cross it out. So what do we get? 3 times 1, which is just 3. Now let's do an example problem together. Find the area of a triangle with the height of 4 and the base of 6. Now what is the formula for an area? It's b times h divided by 2, or 1/2 times b times h. Now let's solve for bh, which is base times height. Now we know that the base is 6 and the height is 4. And we were dividing it by 2. Now what can we simplify by? We can simplify by 6 and 2 or 4 and 2. I think it's easier to cross cancel like this. And you can do it either way. And you get 6 times 2 over 1, which is 12. So I hope you understood how to solve for the diameter, perimeter, and area of the circle, and the perimeter and area of the triangle. I hope this video was useful for you. Thanks for watching. Bye!
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!